All right. Hello, everyone. Happy Friday. Happy Friday. We are at the end of March. It is March 31st. I'm starting this a little bit early because I have to be at the airport in 4 hours. And if I can get this done earlier, that's better. I had to do some things for my day job early this morning. It was a packed week. It was a hectic week and it was a crazy week. And but I just got to get this live stream in. This live streaming, it's fun. It has its moments. It has its fun moments. It has its not so fun moments. But I just had to get this one in. Super Tris, thank you for leaving that comment. D Scott, thank you for showing up. Let me um, gather myself here, and then I'll get this going. My plan is to be on and off in about an hour. All right. How about let me today? Okay, so today we're gonna do some astronomy. I'll just my mind is kind of going all over the place right now. This is my favorite NASA shirt. I have another one. Sometimes you lose things and things get up and walk away and you don't know where they are, or maybe they're buried somewhere. I have another NASA shirt. I have a Arlington Planetarium shirt that I was going to wear for this. Sometimes things get lost and they just get up and walk away or something like that. Anyway, what I'm going to do, we're going to talk some astronomy today, and we're going to talk about whether or not what happens outside the Earth can impact its climate. As I will describe, I've described uh, in content earlier this year that the whole climate discussion is a very, very prickly pear. It's a very, very polarizing discussion, like a lot of other things in this world and in this society. And I think it's important when important. Well, should I use the same word? I think it's important when critical topics are being discussed. It's important to at least understand. It's important to understand what's being discussed so that people are not talking over you and talking uh, and so that you're informed. It's important for the average citizen to be informed. And this discussion, it's very nuanced. It's very polarizing. I'm learning more about both sides. I've downloaded the IPCC, yeah, the IPCC's last report that stands for the Intergovernmental Panel on Climate Change. I've gotten a little bit through the report. It's a big report, but I just want to understand everything that's being said and everything that's being talked about and everything that's being debated in its totality. So I'm going home to visit my mother, my family in Buffalo this week. And so I'm sorry, this weekend. Unfortunately, I can't stay the whole week. But the polar bears will inevitably come up, and the polar bears dying will inevitably come up, and how we're killing the earth, that will inevitably come up. And it's just important to understand all parts of an argument or all parts of a discussion should someone pull you into that discussion. So, today we're going to talk about the Milankovitch cycles, what they are, and how those impact the Earth, and how those may impact climate. And we're going to talk a little bit about timescales. And I think whoever watches this, we're going to learn something. I think the beauty of this channel is that it's forcing me to learn. I think at this stage of my life, I've taken an interest in science communication and science media. So I was trained in a specific area, but science is broad. And the beauty of this channel is that it's forcing me to learn. I haven't monetized the channel yet. I don't have AdSense or a super chat over here yet, but it's information is arguably more important than money. Speaking of which, if anyone wants to make a donation to the channel, my Cash App and PayPal are here. I am going to play the intro and then I'm going to get started because I have to be at the airport in 4 hours. And if I'm not, then my weekend will be ruined. A lot of people's weekends will be ruined. Let me make sure I can see myself on YouTube. I think the fact that Super Triz and D Scott commented means that I'm broadcasting because StreamYard broadcasts to YouTube. Yep, I see the live logo there, or the live icon. Yep, there's me. So I'm gonna play this, my intro, and I'm gonna share this over to my original Big Discussions 76 channel. And then after the intro, we're gonna learn a little bit about the Milankovitch cycles. We're gonna talk about some astronomy and climate. And this is for educational purposes only. Really, Chris, thank you for stopping through. Always good to see you. Thank you. Everyone, please hit that like button. I'm going to play the intro and then I am going to start. So, Super Triz, I'm going to read your comment here. He says, I would guess hotter summers and colder winters as the Earth's orbit increases in eccentricity. The question is, does the duration of orbit remain the same? Yeah, so yeah, this is a very, very complex topic, Super Triz, and I think it's much more complicated than the average citizen knows and understands. I think the average, and I talked about this with an economist and a social scientist over on my original channel. The average American doesn't have the time or the patience to research things and to look up things and to fact check what they're being told and what they're being taught, and what messages they're getting from uh, pop culture, the mainstream media, the political class. Most people just don't have the time or the focus or the patience. Okay, let me play my intro, and then I'm going to jump in and we're going to talk about the Milankovitch cycles. All right. Good morning, everyone. So we're going to talk a little bit about the Milankovitch cycles, and this is highly this is going to be a lot of astronomy. Well, this is going to involve astronomy, and as I'm thinking about this, I volunteered for a season at the Arlington Planetarium. I've talked about that here. That opened back up after it's recently opened back up since COVID. Well, COVID is kind of trending down. But I think Mike Rizzi's comment here is significant because I volunteered on a board there. I was the only melanated person. I'm sorry, let me slow down. I was the only melanated person on the board. And I think one of the reasons they wanted me to be a part of the board was to bring more minority kids over. And so if you're from the DMV, you know where Arlington is, and you know where PG County is, and PG County is where a lot of melanated people live. You have melanated people in Arlington County and Fairfax County and Montgomery County, but they're highly concentrated in PG County. So, to make a long story short, I did not see a lot of melanated people come over to the planetarium to learn about exoplanets, black holes, space time dilation. These are all things that you learn about when you are in astronomy circles, Goldilocks zones, habitable zones, um, reusable rockets. That's a whole different conversation than pearly things. That's a whole different conversation than some of it's a whole different conversation than the things that we normally talk about in our community. So it's no surprise. I didn't know about the Milankovitch cycles until I started learning about the astronomy world, and even until I started kind of taking a closer look at the climate debate. So that's a significant comment. Yeah. So there's just speaking of pearly things. I don't want to. This is not about pearly things, but I was just thinking that there's a lot going on right now. There's just a lot going on right now. So I appreciate you all being here. And so let's learn something. Let's learn something. There's a lot going on YouTube, in the digital spaces, and just the world itself. So I'm going to start with this slide here. I was confronted with this a little while ago. Do you believe in science? And I cobbled this slide together for myself, but also for the audience as well. And this slide asks, do you believe in science? So science is asking why. Science is considering alternative hypotheses. Science is having a flexibility of mind. Science is generating hard data. Science is not believing things blindly and not following things blindly. Science is peer reviewing data. So having people look at your data and question your data and ask questions about your data. That process is painful, but that's a part of it. And then finally, science is thinking critically and questioning. So, do you believe in science out there? You guys, do you believe in science? The climate discussion, again, this is a very, it's like politics. It's a very, very polarizing discussion. It's a very emotional discussion for some people. So, I'm kind of tiptoeing around this myself, but this is a science channel, and it's a very, very intriguing conversation and discussion as well. So, in some of my own research about the debate, not taking a side, someone presented a slide that I thought was interesting when when thinking about climate. So these are things that the layperson does not know. The person who has not researched this, the person who has not actually read about it. These are all things, and I believe this to be true. These are all things that one must understand to understand climate. It involves an amalgamation of astronomy, solar physics, geology, geochronology, geochemistry, sedimentology, tectonics, paleontology, paleoecology, glaciology, climatology, meteorology, oceanography, ecology, archaeology, and history. Okay. So there are when you study this and you study talks, you start to realize that there are a lot of disciplines and a lot of areas rolled up into this one discussion. And there are a lot of people involved in this discussion on the opposing sides. At some point, if I'm feeling brave enough, I'll start to talk about some of the names involved in this very, very polarizing discussion. But today I want to talk about outer space and how things happening with the earth and outside of the earth may impact what we're seeing here on the earth's surface. So I'm going to disappear for a second. I'm going to show you guys the background of this stream, and then I'll come back and then I'll jump in because I think this GIF, it really, really sets the stage for this discussion. So I'll be back in a couple of seconds. All right. Oh, so what was that GIF showing us? I mean, I know what it's showing us. You could see it, but what that GIF is showing us, that's our solar system minus Pluto. Pluto was demoted from being a planet, but the Earth, our planet, is in a solar system with 7 other planets and our sun. It's in its own ecosystem. All the planets are orbiting the sun based upon the gravitational pull of the sun, and the sun provides it gives off a gravitational field. Well, it has a gravitational field, and it gives off a radiance, which in part makes life possible on this planet. And what makes the Earth unique regarding the other planets in the solar system is that the Earth sits within what's called the Goldilocks zone or the habitable zone. And so the Earth is the optimal distance from the sun to sustain and to create and sustain life. So the Earth, we have a breathable atmosphere, and we have water. Okay, and the temperatures, they vary depending upon where you are on the Earth, but the temperatures are suitable for life, and water is critical for life. So the Earth sits in a what's called a Goldilocks zone. Any closer to the sun would be too hot. Any further from the sun would be too cold to have water. So that's what that GIF is telling us. So then the question is, aside from the fact that the Earth is in this ecosystem with 7 other planets, the solar ecosystem, what other dynamics are taking place that may impact life as we know it on the surface of the Earth? I see folks rolling in. Ray Alexander. Ray, we're not talking about social class or the kind of car I should drive today. We're talking about a little bit of astronomy. Kareen from House of Trades, thank you for stopping through. some of the folks in the chat, the names change a little bit. Toya, son, Toya, the tutor, Kareem from House of Trades, Kareem, not Karen. So let's talk about the Milankovitch cycles. I have two pieces to read here from NASA, and these aren't long, but they're really, they are really good food for thought. And again, these are things that the average American is not thinking about. The average citizen is not thinking about um, when hearing debate over climate. And so this gets to, are there things happening that are out of man's control? We see, we go outside and we sense if it's warmer or if it's colder. We sense if uh, weather patterns are different from year to year. We sense if things are going to one extreme or the other. But what things are naturally happening and what things are we as human beings influencing? And interestingly, before I jump in, on my work related field trip last week, we went to Florida, which is hurricane central, and I spoke to a farmer, and I did ask this farmer, have you noticed your rain patterns changed? Have your precipitation patterns changed in recent times? And he says, no, they've remained the same, quote unquote. If I heard him correctly, he said there was no change. And these are farmers, and farmers rely on their production is dependent upon the weather and the climate, or it's impacted by the weather and the climate. Okay, so what are the Milankovitch cycles? And if you listen to climate scientists talk and debate, this is a term that comes up. And as I go through this, see why. Now, before I read this, let's look at the elements that are involved in the Milankovitch cycles. And this is actually the actual thumbnail for this stream. And wouldn't you know, I don't have it queued up. That's my computer saying rush. Here we go. The Milankovitch cycles. And as with most things NASA and space related, Milankovitch was an actual scientist. And this was such a significant finding that they named this phenomenon after him. Okay, so the Milankovitch cycles. So as I read through this, we're going to go over three elements here. All right, so eccentricity. So that's referring to alterations in the Earth's orbit around the sun. And then tilt, I think that's self-explanatory. The Earth is not, it's not sitting upright relative to the sun, it's tilted, but that tilt seems to vary. And then looking at precession, that's dealing with a wobbling. I'm going to call it a wobbling of the Earth. So on the surface, until there's an earthquake, as far as we're concerned, everything is normal, everything is fine until there's an earthquake. But according to this information, the Earth is the tilt is not the tilt is a little bit fluid, and also the globe itself, it wobbles to some degree as it's traveling around the sun. And according to what we're about to read, over the long term, over a long term time scale, that's another term that comes up when you hear climate scientists debate. Over a long term time scale, these factors can impact the climate that we see here on our surface. Okay, so let me jump into this. And this was published on the NASA site, and the links are below in the description box. So, Milankovitch orbital cycles and their role in Earth's climate. This was written by Alan Buis from NASA's Jet Propulsion Laboratory. If you hear a buzzing noise in the background, the groundskeepers are out keeping the grounds. All right. And everyone, let me know what you think in the chat as I go through this. Our lives literally revolve around cycles, series of events that are repeated regularly in the same order. There are hundreds of different types of cycles in our world and in the universe. Some are natural, such as the change of the seasons, annual animal migrations, or the circadian rhythms that govern our sleep patterns. Others are human produced, like growing and harvesting crops, musical rhythms, or economic cycles. Cycles also play a key role in Earth's short term weather and long term climate. A century ago, Serbian scientist Milutin Milankovitch hypothesized the long term collective effects of changes in Earth's position relative to the sun are a strong driver of Earth's long term climate and are responsible for triggering the beginning and end of glaciation periods or the ice ages. So now we're getting into time scales. And that's an important vocabulary word when you hear climate scientists debating about who's right and who's wrong. Time scales. And you also start hearing about ice ages. Okay, you got me here. Specifically, he examined how variations in three types of Earth orbital movements affect how much solar radiation, known as insolation, reaches the top of Earth's atmosphere, as well as where the insolation reaches. These cyclical orbital movements, which became known as the Milankovitch cycles, cause variations of up to 25% in the amount of incoming insolation at Earth's mid latitudes, the areas of our planet located between about 30 and 60 degrees north and south of the equator. The Milankovitch cycles include the shape of the Earth's orbit, known as eccentricity, the angle Earth's axis is tilted with respect to Earth's orbital plane, known as obliquity, and three, the direction Earth's axis of rotation is pointed, known as precession. Okay, let's take a look at each. So this cartoon, everyone, that shows eccentricity. So if you look at that orbit, you could see, according to this depiction or this illustration, that the orbit is changing. It's not a fixed, it's not a fixed ellipse around the sun. So scientifically, one might expect that as the Earth goes further away from the sun, it may get a little bit cooler. Now, this is just for educational purposes. The Earth's not moving that fast, but this is the principle of eccentricity. And this is a part of this principle of the Milankovitch cycles, is that uh, the orbit, it varies. And in some instances, the Earth goes further away from the sun. Fair use, YouTube. This is for educational purposes only. I don't think this would be a copyright strike of any kind. This is basically a GIF on the NASA website. Salute to Alonzo Hall, the All-Star Advisor. Thank you for stopping through. Everyone, please like, share, and subscribe. And everyone, keep in mind also, melanated people, we lag behind in the sciences and the STEMs. So getting this information out can help turn the tide a little bit because there are particularly young people who don't know anything about this stuff. Okay, so please share this. This is harmless. On your Facebook timelines where there are young people that you know, please share this. So this is eccentricity. And that says 100,000 year cycles. Okay. Eccentricity. Earth's annual pilgrimage around the sun isn't perfectly circular, but it's pretty close. Over time, the pull of gravity from our solar system's two largest gas giant planets, Jupiter and Saturn, cause the shape of the Earth's orbit to vary from nearly circular to slightly elliptical. Eccentricity measures how much the shape of the Earth's orbit departs from a perfect circle. These variations affect the distance between Earth and the sun. Okay, so I just learned something there. We just learned something there. So if you go back to the GIF here, let me drop myself down so you guys can see what I'm talking about. You see all those planets orbiting the sun from what we just read. Saturn and Jupiter are pulling on Earth such that at certain times it changes our orbit around the sun from circular to more elliptical. And one would suspect that the further you go away from the sun, that's going to make you probably a little cooler. Okay. Eccentricity is the reason why our seasons are slightly different lengths, with summers in the northern hemisphere currently about 4.5 days longer than winters, and springs about 3 days longer than autumns. As eccentricity decreases, the length of our seasons gradually evens out. The difference in the distance between Earth's closest approach to the sun, known as perihelion, which occurs on or about January 3rd each year, and its farthest departure from the sun, known as aphelion, on or about July 4th, is currently about 5.1 million kilometers, or about 3.2 million miles, a variation of 3.42%. That means each January, about 6.8% more incoming solar radiation reaches the Earth than it does in July. When Earth's orbit is at its most elliptic, about 23% more incoming solar radiation reaches Earth at our planet's closest approach to the sun each year than it does at its farthest departure from the sun. Oh, I see. That makes sense. Currently, the Earth's eccentricity is its least elliptical or its most circular and is very slowly decreasing in a cycle that spans about 100,000 years. The total change in global annual insolation due to the eccentricity cycle is very small because variations in Earth's eccentricity are fairly small. They are relatively minor. They are a relatively minor factor in annual seasonal climate variations. So this cartoon represents changes in oblique, I'm sorry, obliquity, obliquity, obliquity. So I'm going to play this one. Let me shrink that a little bit. Obliquity. Okay. So you can see there the Earth is tilting like this. Okay. I'm going to blow this up so I can read it. Obliquity. That comes out kind of awkward. Obliquity. Obliquity. Okay. Obliquity. The angle Earth's axis of rotation is tilted as it travels around the sun is known as its obliquity. Obliquity is why Earth has seasons. Over the last million years, it has varied between 22.1 and 24.5 degrees with respect to the Earth's orbital plane. The greater Earth's axial tilt angle, the more extreme our seasons are. As each hemisphere receives more solar radiation during its summer, when the hemisphere is tilted toward the sun, and less during winter when it is tilted away. Larger tilt angles favor periods of deglaciation, the melting and retreat of glaciers and ice sheets. These effects aren't uniform globally. Higher latitudes receive a larger change in total solar radiation than areas closer to the equator. The Earth's axis is currently tilted 23.4 degrees, or about halfway between its extremes. And this angle is very slowly decreasing in a cycle that spans about 41,000 years. It was last at its maximum tilt about 10,700 years ago and will reach its minimum tilt about 9,800 years from now. As obliquity decreases, it gradually helps make our seasons milder, resulting in increasingly warmer winters and cooler summers that gradually over time allow snow and ice at high latitudes to build up into large ice sheets. As ice covers, as ice cover increases, it reflects more of the sun's energy back into space, promoting even further cooling. Okay, so guys, what do you notice about time there and what we as human beings, what we would experience in terms of the timing of these events? What do you guys notice about that? Just some food for thought. Please hit that like button if you haven't. Please subscribe to the channel if you haven't. What do you guys notice about time? Anyone? Okay. So again, I'm asking just for some participation here, just to get everybody to think. For these natural alterations in Earth's climate and these phenomena we're looking at here, in terms of the human lifespan and what these phenomenon are, what do you notice, or what should occur to you? Giagami, that's right. So these changes are over thousands of years, and our lifespan, well, the average man, I think, now lives to be about 70 years of age. So in our lifetimes, we're only seeing a small speck of these changes. Now, these are the natural changes. This isn't getting to what humans might be doing to the earth, but for these changes that we're talking about, we we're only going to see a small snapshot of these changes as they're taking place. Yeah. So axial precession, or the wobble. This is a depiction of the wobble, not the dance, not the song, but the Earth's wobble. Okay. YouTube, this is for educational purposes only. There shouldn't be a copyright strike associated with this. So you can see with that wobble, how that pole is moving in a circular motion. It's not static, it's fluid. So from what we're learning here, apparently those variations are sufficient to, I'm assuming that would impact those ice sheets, those polar ice sheets there. So this wobble phenomenon is very, very significant for the size and the size of those polar ice sheets. Yeah, guys, keep commenting there. Those comments are very, very helpful. Okay, so axial precession. Let's read about that. And this is almost done. As Earth rotates, it wobbles slightly upon its axis, like a slightly off-center spinning toy top. This wobble is due to tidal forces caused by the gravitational influences of the sun and moon that cause Earth to bulge at the equator, affecting its rotation. The trend in the direction of this wobble relative to the fixed position of stars is known as axial precession. The cycle of axial precession spans about 25,771.5 years. I'm going to blow this up for myself. My eyes are good, but I don't want to strain them if I don't have to. All right. Axial precession makes seasonal contrasts more extreme in one hemisphere and less extreme in the other. Currently, perihelion occurs during winter in the northern hemisphere and in the summer in the southern hemisphere. This makes southern hemisphere summers hotter and moderates northern hemisphere seasonal variations. But in about 13,000 years, axial precession will cause these conditions to flip, with the northern hemisphere seeing more extremes in solar radiation and the southern hemisphere experiencing more moderate seasonal variations. Precession does affect seasonal timing relative to Earth's closest slash farthest points around the sun. However, the modern calendar system ties itself to the seasons. And so, for example, the northern hemisphere winter will never occur in July. Today, Earth's north stars are Polaris and Polaris Australis. But a couple of thousand years ago, they were Kochab and Percad. There's also apsidal precession. Not only does Earth's axis wobble, but Earth's entire orbital ellipse also wobbles irregularly, primarily due to its interconnections with Jupiter and Saturn. The cyclical the cycle of apsidal precession spans about 112,000 years. Apsidal precession changes the orientation of Earth's orbit relative to the elliptical plane. The combined effects of axial and apsidal precession result in an overall precessional cycle spanning about 23,000 years on average. So, again, everyone, for these natural changes for our lifespans, we will only see a snippet of these changes. And then the question is, where are we on these changes? And what are the larger impacts on the changes we're seeing? And how do these relate to the changes that we're seeing? These are long-term timescales, but relative to what we're seeing outside, what does this mean? Does this mean anything? Is this significant? Okay, just some food for thought. This one is almost done. Let's see. The small changes set in motion by Milankovitch cycles operate separately and together to influence Earth's climate over very long time spans, leading to larger changes in our climate over tens of thousands to hundreds of thousands of years. Milankovitch combined the cycles to create a comprehensive mathematical model for calculating differences in solar radiation at various Earth latitudes, along with corresponding surface temperatures. The model is sort of like a climate time machine. It can be run backward and forward to examine past and future climate conditions. Milankovitch assumed changes in radiation at some latitudes and in some seasons are important than others. Let me read that again. Milankovitch assumed changes in radiation at some latitudes and in some seasons are more important than others to the growth and retreat of ice sheets. In addition, it was his belief that obliquity was the most important of the three cycles for climate because it affects the amount of insolation in Earth's northern high altitude regions during summer, or in other words, the relative role of precession versus obliquity is still a matter of scientific study. He calculated that ice ages occur approximately every 41,000 years. Subsequent research confirms that they did occur at 41,000 year intervals between 1 and 3 million years ago, but about 800,000 years ago. The cycle of ice ages lengthened to 100,000 years, matching the Earth's eccentricity cycle. While various theories have been proposed to explain this transition, scientists do not yet have a clear answer. Milankovich's work was supported by other researchers of his time, and he authored numerous publications on this hypothesis. But it wasn't until about 10 years after his death in 1958 that the global science community began to take serious notice of his theory. In 1976, that was a good year. 1976 was a very good year for my purposes. In 1976, a study in the journal Science by Hayes et al., or Hayes, using deep sea sediment cores, found that Milankovitch cycles correspond with periods of major climate change over the past 450,000 years, with ice ages occurring when Earth was undergoing different stages of orbital variation. Several other projects and studies have also upheld the validity of Milankovich's work, including research using data from ice cores in Greenland and Antarctica that has provided strong evidence of Milankovitch cycles going back many hundreds of thousands of years. In addition, his work has been embraced by the National Research Council of the United States National Academy of Sciences. Scientific research to better understand the mechanisms that cause changes in Earth's rotation and how specifically Milankovitch cycles combine to affect climate is ongoing. But the theory that they drive the timing of interglacial cycles is well accepted. All right. So that's that one. Very cool stuff, right, guys? Very cool stuff. This link is below in the description box, but I will drop it in the chat right now. I think at the very least, what this tells us is that the Earth's temperatures and what we as humans perceive and what we see, there are a lot of processes going on, some of which we don't completely understand. And based upon these shifts in the Earth's orbits, how the globe is tilting and how it's wobbling, and it's doing those things, there are things that we don't completely understand. And then it gets more complex when you start speculating on what happens when you put more carbon dioxide up in the atmosphere. Um, there are a lot of things happening at once here. I think that's one of the takeaways everyone should get from this. Okay, I'm going to do one more. I'm going to take a quick run to the RR, and I'll be back. But everyone, just also think about how astronomy impacts this and how things outside of our planet are affecting our planet. There's the Earth and the Moon, and then there's also Saturn and Jupiter at certain times pulling on us, pulling on our planet. Think about how complex this is. I'm going to run to the RR, the R squared, and I will be right back. Please bear with me. I will not be long. I have to get to the airport by a certain time. All right, everyone. Sorry about that. I might edit that down on the replay on YouTube. You can do that. So, again, my backgrounds are in pharmacology and toxicology. I am a genuinely curious person, and I have a science channel. So, if there's someone who is knowledgeable in this area and you want to come and talk about it, whether you are a climate alarmist or whether you are a climate denier, or whether you are somewhere in the middle and you're undecided and you have a background in these areas, my door is open to come and talk. I like to talk to people. I like to ask questions. Science is about asking questions for the greater good and the greater knowledge. So I can be reached here at that email address. I know it's a mouthful, bigdiscuss76 at bigwordsarepowerful.com. Uh, Respectful discussion is welcome here. Curiosity is welcome here, and critical thought is welcome here. All right. So I have another link from NASA that I'm going to read. Okay. A slightly different tone. That one was kind of neutral. This one is kind of saying, whoa, 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 wait a minute, everyone. All of you climate deniers out there, don't you take these Milankovitch cycles, and that doesn't say that man is not, we're not hurting the earth or destroying the earth. But there's something interesting in this piece that I think is worth noting. And when we get to it, I will stop. Once again, everyone, if you want to make a donation to the channel, my Cash App and PayPal are there. I don't have AdSense or Super Chat. So if you want to drop something in the collection plate, as another prominent content creator says, you're welcome to do so. All right. This is a well, I'll read the title for you once I cue it up. So, before I get into this, so again, understanding these conversations is huge because if you just listen to what's being said, and again, I think it's important just to understand what's being said, and it's important to be able to speak the language and to know who's talking about what and why, and whether or not what they're saying is factual. People, when they hear the news, when people hear news about the earth is going to end tomorrow and it's going to burn up in a ball of fire, people are making life decisions on that. People are deciding whether or not to have children based upon that. People's moods are swinging based upon that. People's personal well-beings are swinging based upon those sentiments. So it's important just to understand what's being talked about and whether or not the end is going to be tomorrow or 10 years from now or 50 years from now or 1,000 years from now. It's important to understand. Okay. So this blog is also from NASA, and it's saying, whoa, wait a minute. Just because we have these Milankovitch cycles, that doesn't mean that, there's not something man-made going on. So here I like to have balance, and there's something interesting in here that I think is worth noting. Okay, so this was written by, well, same guy, Alan Buis from NASA's Jet Propulsion Laboratory. There's a pretty picture of the Earth and the sun in the background. I don't know. Well, yeah, this is an artist's concept of Earth and the sun. So that's not a real image, but it's a pretty image nonetheless. Okay. In the last few months, a number of questions have come in asking NASA. Um, sorry, let me read that again. In the last few months, a number of questions have come in asking if NASA has attributed Earth's recent warming to changes in how Earth moves through space around the sun, a series of orbital motions known as Milankovitch cycles. What cycles, you ask? Milankovitch cycles, we just read about these, include the shape of the Earth's orbit, its eccentricity, the angle of the Earth's axis is tilted with respect to Earth's orbital plane, its obliquity, and the direction that Earth's spin axis is pointed, its precession. These cycles affect the amount of sunlight and therefore energy that Earth absorbs from the sun. They provide a strong framework for understanding long-term changes in Earth's climate, including the beginning and end of ice ages throughout Earth's history. I think he's linking to his previous piece. This is a summary of what we just read. orbital cycles, changes in eccentricity, and axial precession. Okay, let me shrink that so you can see all three cartoons, all three illustrations at once. And guys and gals, these links are below in the description box in case you want to keep copies for yourself. All right, I'm going to blow this back up for myself. Okay, so here we go. But Milankovitch cycles can't explain all climate change that's occurred over the past 2.5 million years or so. And more importantly, they cannot account for the current period of rapid warming Earth has experienced since the pre industrial period, the period between 1850 and 1900, and particularly since the mid 20th century. Scientists are confident Earth's recent warming is primarily due to human activities, specifically the direct input of carbon dioxide into Earth's atmosphere from burning fossil fuels. My only issue with what my only issue with what he wrote there is that when you say scientists are confident, I would change that to some scientists are confident because not all of them are on the same side with this. Okay. So how do we know Milankovitch cycles are not to blame? First, Milankovitch cycles operate on long time scales. There was that vocabulary word again, time scales, ranging from tens of thousands to hundreds of thousands of years. In contrast, Earth's current warming has taken place over time scales of decades to centuries, so 10 to 100 years. Over the last 50, over the last 150 years, Milankovitch cycles have not changed the amount of solar energy absorbed by the Earth much. In fact, NASA satellite observations show that over the last 40 years, solar radiation has actually decreased somewhat. So that's speaking to the sun's output is not uniform. The sun's output is increasing and decreasing. It's increasing and decreasing. So the sun has its own cycles. That's what that's speaking to. You see how complex this thing is? Okay. Second, Milankovitch cycles are just one factor that may contribute to climate change, both past and present. Even for ice age cycles, changes in the extent of ice sheets and atmospheric carbon dioxide have played important roles in driving the degree of temperature fluctuations over the last several million years. The extent of ice sheets, for example, affects how much of the sun's incoming energy is reflected back to space and in turn Earth's temperature. Then there's carbon dioxide. During past glacial cycles, the concentration of carbon dioxide in our atmosphere fluctuated from about 180 parts per million to 280 parts per million as part of Milankovitch cycle driven changes in Earth's climate. These fluctuations provided an important feedback to the total change in Earth's climate that took place during those cycles. So that even says that there's a natural there's a natural fluctuation in carbon dioxide in the atmosphere. Today, however, it's the direct input of carbon dioxide into the atmosphere from burning fossil fuels that's responsible for changing Earth's atmospheric composition over the last century, rather than climate feedbacks from the ocean or land caused by Milankovitch cycles. Since the beginning of the industrial age, the concentration of carbon dioxide in Earth's atmosphere has increased 47% from about 280 parts per million to 412 parts per million. In just the past 20 years alone, carbon dioxide is up 11%. Okay. Scientists know with a high degree of certainty this carbon dioxide is primarily due to human activities because because carbon produced by burning fossil fuels leaves a distinct fingerprint that instruments can measure. Okay, I think this is the statement that I read that stood out to me. Since 1850, since 1850, Earth's global average temperature has increased by over 1 degree Celsius or 1.8 degrees Fahrenheit. Furthermore, recent scientific assessments show that Earth is expected to warm another half a degree Celsius, almost a degree Fahrenheit, as soon as 2030. So let me read that again. Since 1850, Earth's global average temperature has increased by over 1 degree Celsius or 1.8 degrees Fahrenheit. Furthermore, recent scientific assessments show that the Earth is expected to warm another half degree Celsius as soon as 2030. So most of us will be alive to see that, and whether or not that prediction is true. But let's see, 1850, that is 170 years ago. So that is a one. Now they're not specific here. They don't say, they say over 1 degree, but they don't say what that exact number is. Is it 1.1? Is it 1.2? Is it 1.6? But even still, scientifically, again, I'm not a climatologist. Scientifically, over 170 years, over the span of 170 years, that to me doesn't look like a big change. But if someone is watching this, again, from that community and wants to come and talk about it, I'm open to having a Q&A about this because I think it's very, very fascinating. So over 170 years, a 1 degree change. And again, they didn't specify, this person didn't specify, is it 1.1, 1.2, 1.3, but over 170 years, I would expect that you would see some change in some direction. But that's just me. But I guess this is a rapid warning. I'm sorry, a rapid warming. Okay. This relatively rapid warming of our climate due to human activities is happening in addition to the very slow changes to climate caused by Milankovitch cycles. Climate models indicate any forcing of Earth's climate due to Milankovitch cycles is overwhelmed when human activities cause the concentration of carbon dioxide in Earth's atmosphere to exceed about 350 parts per million. Scientists know of no natural changes to the equilibrium between the amount of solar radiation absorbed by Earth and the amount of energy radiated back to space that can account for such a rapid period of global warming. The amount of incoming solar radiation has increased only slightly over the past century and is therefore not a driver of Earth's current climate warming. Since 1750, the warming driven by greenhouse gases coming from human burning of fossil fuels is over 50 times greater than the slight extra warming coming from the sun itself over that same time interval. If Earth's current warming was due to the sun, scientists say we would expect temperatures in both the lower atmosphere, the troposphere, and the next layer of the atmosphere, the stratosphere, to warm. Instead, observations from balloons and satellites show Earth's surface and lower atmosphere have warmed, but the stratosphere has cooled. Okay, I'm gonna have to. I'll be thinking about this on the airplane and afterwards. That let me read that sentence again. Instead, observations from balloons and satellites show Earth's surface and lower atmosphere have warmed, but the stratosphere has cooled. I'm not sure what that means. Okay, that the stratosphere has cooled. I'm trying to reconcile all this. Finally, Earth is currently in an interglacial period, a period of milder climate between ice ages. If there were no human influences on climate, scientists say Earth's current orbital positions within the Milankovitch cycles predict our planet should be cooling, not warming, continuing a long term cooling trend that began 6,000 years ago. There's nothing cool about that. Okay. So that's the second piece. Super Tris, there were a lot of comments here. Super Tris says, I guess the concern then is a runaway greenhouse effect in the vein of Venus. That's the concern. And I think that was the prediction of the hockey stick model. Okay, so now we're going a little bit deeper into the rabbit hole. Um, when you start to learn about the people involved in this discussion and the different parts of it, that was the concern in the late 1990s and early 2000s, but that has not happened. And as a matter of fact, I think the temperature went in a different direction from what the models had predicted, which is part of the controversy of this whole thing. Okay. But certainly, if there was a runaway greenhouse effect or a runaway warming, that would definitely be clear to all of us. Apoteki says, I wonder if Earth's obliquity slash wobble affects its magnetic field, which in turn affects how much solar radiation it absorbs. Super Shriz says, perhaps the upper atmosphere temperature is a result of reflected heat in addition to direct solar radiation. And Super Shriz says, with increased greenhouse gases, more heat is retained in the lower atmosphere and less reflective heat in the upper atmosphere. Okay. So everyone, I just wanted to do this stream on the Milankovitch cycles. This is a term and a principle that came up in studying and learning more about the the debate. And when you listen to scientists talk about which direction the temperature is going, there is a lot of debate about what's actually happening. And this is a principle that comes up in this discussion. So I think for the layperson, for the person in the general public, it's just important to understand what's being talked about and just to understand whether that just to understand it just to understand this principle and just to understand and to ask whether or not this is a valid part of the discussion, and it's important to understand why some scientists are talking about this as a part of the discussion and why some scientists are saying no, it doesn't matter about the Milankovitch cycles, this is what's happening. It's just important to understand and to kind of come to your own conclusions. Yeah. So I am at an hour and 15 minutes. I need to wrap this up. I need to make sure that I the airport on time, and I have to take the rental car back. I heard an alarm going off outside. Of course, I thought about my poor Kia, which is still at the dealership. But yeah, I have to take this rental car back and get to the airport before my departure. So, everyone, thank you for those of you who hung out and humored me and commented here uh, in the chat. Climate is a big deal. It's a big topic. People, there are people who are willing to fight over this, and it's it's a it's a very very contentious discussion with multiple hypotheses and multiple moving parts. Once again, if you want to make a donation, oh, I'm not going to go into that again. Akateki, thank you for the Cash App. Thank you for your continued support uh, for this content and for this channel. I want to continue to grow the channel and have more guests on. Ooh, Super Trish says we need to have a panel discussion about the climate sometime. That would be interesting. That could be interesting. The danger is something like that getting out of control because people it's a very very polarizing topic. It's a difficult discussion to have, and it's something I need to be careful about discussing. I'm trying to, as I present this, I'm trying to kind of stay a little bit neutral and not saying, this side or that side. So let me think about that. Okay. Okay. All right, everyone. I'm going to wrap this stream up. I have to run. Thank you to those of you who hung out. Please consider joining my newsletter. I have been backed up in terms of tasks, so I haven't written one up recently. But the link is below in the description box, and it looks like this when you open it. There's a two-paragraph greeting, and then you just click this subscription button, and it takes you there. Please consider signing up, as I am a writer, in addition to being a YouTube content creator, and I have a book on the way. Aquateki, yeah, this is it right here. As with a lot of things, emotions get ramped up with this, and when you study what's happening in that community, and you study both sides of the community, and you hear stories about what's happening and how people are canceled and people are smeared and people's lives are threatened and people are um, excommunicated and people aren't granted tenure at their universities. It gets pretty ugly. This whole thing gets pretty ugly. So definitely emotions play a role, but I think the challenge with science is to keep it about the science, and I think that's the hard part, keeping it about the data and keeping it about what you can prove and what the facts actually show. That's the hard part in all this, especially for this thing. All right, everyone, I have to run. Thank you for being here. All the links are below in the description box. If you're watching on the playback, please let me know what you think. Please like, share, and subscribe. And as always, remember that your attitude determines your altitude. Always try to do your best. Take care, and I will talk to you the next time. Bye bye.